back and everyone else who's here. This will be a general discussion on academic or general topics. So we're not doing, even though my title is business librarian, it's not going to be business centered. So don't worry about that. A couple of examples were business centered, but we are focusing on general use, widely available academic products. So just scope note for that. Here is our agenda. And Blake Lee and I have the goal of hopefully getting through item 4 within 10 minutes. That item 2 through 4 is really our extended introduction to this topic. And we hope to spend there for most of the time in 5, where we look at least 4 of these products. We may not get to Google Scholar. We've got it open. We might show it, but we may run out of time by then. But we want to spend most of our time today using these tools live and illustrating points we're going to make with items 2 through 4 regarding the different ways, the very nuanced and opt-in, I should add. These are almost all opt-in tools for using AI within these products. Blake Lee, anything else to add for introduction before we get into definitions?
I don't think so. I was just going to introduce myself as
Please.
I'm an MLIS researcher and sociology game designer. And today we're just focusing on AI inside of academic databases. So that's all.
Thank you, Blake Lee. You sounded a little quiet to me. I didn't know if others thought that too. Hopefully I sound okay. I don't know how well I sound to you all today. Feedback on that from Sam or others is welcome. All right, we invite questions about the content anytime, microphones or putting things in the chat. If there's interest in a more general AI discussion, how AI is being used in academic research, we'll welcome that too, but let's save that for the end. And we can also turn off the recording at some point and during this final discussion if people want to ask questions that you don't want to end up in YouTube. So at some point we may say, hey, we're going to turn off recording and then say whatever you want. So that may come up as well. All right, let us go forward then. Over to Blake Lee.
Okay, can you hear me?
Yeah, we can hear you.
Okay. So first we'll do some quick definitions to show where AI appears in the workflow, then demos, and then we'll leave some time for questions. When we say commercial AI, we mean mass market tools like ChatGPT, Gemini, and Copilot. When we say RAG, we mean retrieval augmented generation, which means the system retrieves content from a specific collection and then generates an answer based on that retrieved text. In academic databases, the key idea is closed corpus versus open web. Many database AI features are designed to generate summaries or help discovery using content the library licenses. So 2 specific search modes that we're going to be looking at are Boolean searching, which includes and, or not. Natural language searching is how humans type and ask questions. So this would look like a typical Google search. And then semantic searching is what AI layer tries to do, is interpret meaning and expand and ingest retrieval based on our searches.
So all these, thank you, Blake Lee, all these concepts are going to come up either in the next few slides or when we do this live in a few minutes with some of these products. Any questions, comments, clarifications needed at this point? And again, the introductory, we'll see this live, but we thought it was important to at least get some of this jargon, both AI jargon and library science jargon out there at the beginning. And if something comes up later regarding definitions, please stop us and tell us that. We'll work with that. All right, so let's get into what AI can do. Here is the classic nature of a database search. Searching at Go Progress to library catalog, even Google Scholar. This is what generally happens, right? You type in keywords, it runs the search, it decides how to rank them. Typically, the number of words in your search that appear in the title, citation, and abstracts of the articles, assuming we're looking at a journal citation database or journal database, are what determines relevancy and ranking. And then you get a list of results, and you choose to look at one or more articles, right? So the classic 5 steps of how research, with CD-ROMs, it's the same way. With dial-up systems, when I was in library school in the 1990s, graduate school, we used that too. So this is classic parameters for how you do research. But with AI, potentially, notice that the first word on this slide is possibilities. Possibilities exist for different AI roles. And this is one reason why we really want to emphasize nuance here. It's hard to be I think thoughtful, I don't put it that. We need to be thoughtful about and nuanced about when we talk about AI in research because it can do many different things. And each of the red circle concepts here is an example of that. So for example, you can type in a keyword search and we'll show you this live with EBSCO in a few minutes. AI can generate a more complex search string using semantic searching. It knows about connected keywords. It's doing predictive algorithms of text. If you see this word usually follows it, or if you see this phrase is connected to it, and generates a more complex Boolean search, Boolean being the thing where you have like Chaucer and Boccaccio and Petrarch, etc. And then you run the search. A ranking happens still. It could be a traditional ranking algorithm, or it could be a more semantic ranking. And it's hard to tell which is being used. The system isn't that obvious about which kind of ranking is running. Typically, if it's slower, it's AI ranking it. If it's pretty quick, it's the standard ranking algorithm the database has been using for years. And I know the right side of this slide looks complicated. So let me break it down into two pieces. Typically, after you run your search, the algorithm runs, you get results. And then bottom right, you get an article. And then there may or may not be a fixed summary. EBSCO, for example, has a summary that is pre-composed by AI. It never changes. Everyone sees the same summary. They do, by the way, EBSCO has, by the way, a collection of editors who do a sampling of all those fixed AI summaries and make sure they look accurate. They don't look at every single one. They don't have capacity to do that, but they do provide some human control over it to make sure that based on the sampling, it works well. Or it's dynamic. ProQuest does this, and Blake Lee is going to show you that, how it does give you some standard text, but also shows you how your keywords impacted the search and got you that article. Like you got this article because your keywords showed up here. Dynamic summary in that regard too. And then finally, jumping up to the top right, you might also have an option to see a narrative summary. AI might make a summary. You did a search here, top 25 hits. According to these top 25 articles, here is the nature of this research topic. Here is the answer to your question even. And certainly that is the most risky and the most, controversial aspect of AI in academic research. And we'll show you an example of that with Statista, which looks at statistics and gives you an answer for that. But also you might see a summary table. It might give you a table with 25 articles, the authors, the citations, the main point or the abstract, why your keywords came up, and that could be a table that you can use to compare articles. We're not going to show you an example of that today. And you have used Cite AI, which the business school has license for. You may have seen tables results. So just 5 different ways AI can work. A database may only use one of these 5. It may use 2 or 3. No one's using all of them. And again, almost all of these are optional. You have to choose to get the complex search done, the semantic search, or you choose to see the summary at the end or not. So we'll show you examples of that as we go along. And to conclude these 2 slides, back to Blake Lee.
So today we'll keep asking the same question. Where does AI kick in and what is it doing? That's how you'll stay critical and in control. Anytime you see an AI badge in a database, ask, is it changing retrieval, ranking, summarization, or interaction? We're talking about semantic searching. We would say that AI expands or interprets meaning, so your search finds more relevant items. For semantic sorting and ranking, AI may reorder your results, and that may be harder to detect than a visible summary. For summarizing results and providing answers, RAG-style summaries of a results list. And summarizing a single item is when you would chat with an article, chapter, or report. And are we transitioning now into demos?
Yeah, one more topic.
Okay.
We'll keep this quick because we do want to get to our hands-on part, but this will be short. For those of you, thank you again, who attended my talk 2 weeks ago on prompt engineering. You heard me talk about recommend that you all have your students to generate very complex, detailed, long prompts to do academic research using the commercial tools such as ChatGPT or Copilot. However, in a RAG environment where you're searching a very small set of research, you don't necessarily need to get that fancy. So here are 2 examples. We're not going to show Mintel live. It's too specialized. It's a market research tool. But just 2 searches I've done to illustrate how you can keep it short and get what you need. So this real topic I did for a class last semester, market data on Halloween spending. And notice that's all I typed in, those 5 words, and that was totally sufficient because Mintel is only looking at a collection of about 500 reports it has on market data, including one on holiday spending patterns. This footnote there at the end of paragraph 1.1 goes to their report on holiday spending. And so there you go. You could do very short prompting and get, in this case, good results. Another aspect of this too, it's I don't want to be too binary, and say yes, or it always works or never, in this case, because that's not necessarily true. But it's really rare to see hallucinations when you're doing a RAG search. So again, this is searching just market research reports from this one company. There's only about 500 because they delete old ones when they add new ones when they update them. And it didn't have any data on this topic. And it said that. It said, I can't do this. It did tell me I had some other things about healthcare and some personal care categories like shampoo and maybe makeup, but I can't do contact lenses. So that was it. I had to, use a different source, which I did find for this content. So that's just a note about prompt engineering. It doesn't have to be fancy within some of these very specialized products. Okay. Any questions, comments, ideas regarding the introduction before we stop sharing screen and switch over to web browser? Stop sharing slides, I mean. Are you ready to see some of this in action?
Yeah, there's no questions in the chat,
Okay,
so I think you're good.
Giving people a chance to do that. All right, I'm going to show semantic searching in EBSCO, and then Blakely is going to talk about ProQuest summaries, and JSTOR actually is a little more out there. And then finally, we'll look at Sista, which does provide answers, where it tries to provide AI summaries of a searching. Go Scholar if we have time, but I don't think we're going to have time for that. So just you might want to try that if you have interest in this too. All right, so I'm going to stop sharing, and then go to web browser, and Blakely and I, of course, will be alternating sharing. So forgive us for a few seconds of doing this. And I'm going to go academic search complete. This is new to us. EBSCO turned this on for us last week. I had to go in and fix our slides. From the simple search of any EBSCO product, there's option now for natural language search. So I mentioned opt-in, right? If you don't want to use AI, you don't have to. The default is not to. But I'm going to turn that on. And I'm going to save time. I have a existing keyword search, or not, sorry, natural language search. I'm going to cut and paste. I've got a document here. What are trends in fertility rates in Japan? And then I'm going
Hey,
to search.
Steve, just FYI, Audrey asked if you could slow down a little bit.
Okay, yeah, I'm sorry. I talk fast all the time, and I need to do better. I apologize. So we have results like you do in a normal EBSCO search, but one new thing on screen is this link underneath the search bar for show refined query. So this is important, right? Transparency and research. What exactly did you look for, EBSCO? Well, here's the answer. Trends or patterns or changes or developments, and another set of keywords, and Japan. A notice in the middle, fertility rates is what I used, but birth rates, a related concept. So that's semantic searching in action. It's finding related concepts. Or reproductive rates, that I don't know if that's a common phrase or not, but okay. Or net, I can't say that last word, natility, is that how you say that? So that was semantic searching happening, finding related phrases or keywords and adding it to a technically correct Boolean search. If I want to refine this, I can copy this text. I kind of wish they could do this automatically. And then paste it into my search as a standard search. It's going to redo my search. And let's say maybe I want to add a country. I know this is also an issue in Italy and many other countries actually. Or maybe I don't like this phrase, reproductive rights or nativity. I can, I obviously delete things as we go along. And therefore flexibility, and I like how it enables us to see what happened and then if we want to fix it up and go from there. And that was an example of semantic searching, where it takes a natural language, normal human question asking, sentence writing, could be a phrase as well, and turning it into a Boolean search where it basically makes it better. Questions, comments on this example? And hopefully I eventually talked slower. I get excited by that. I think this is interesting. I don't think it's perfect or even, what we always want to happen, but it's important to know this stuff. I get excited and I talk fast, so forgive me for that. I'll try to do better. All right, let's go one step forward. We're going to turn over to Blakely. I'm going to stop sharing and let Blakely share. We're going to look at how ProQuest, once we have an article on screen, will gives us options for summarizing it.
Okay, thank you, Steve. I'm going to try and share my screen. Let's see. Okay. Let's see. Is everyone able to see my script research library?
Yeah, it's on ProQuest Research Library.
Okay. Okay. So I'm going to show you the difference between fixed summaries in relationship to your terms, and also a visualization mind map using ProQuest. So I'm going to search Sable Island and Grace seals and breeding. And so once I search that, oh, first you must be logged in with your account because that is when the AI research tool is available. Once you have your results, you will click on an article. And over here, you can see that there's a summary, short takeaway to help you evaluate the source. You can ask questions and it gives you key concepts in terms. So for example, you could ask, so behavioral interaction. So I could ask, what common behaviors? So it can generate a response related to what it knows about the text. So it's not pulling any other resources, but what's provided here. So here it can list the most common behaviors observed and make sure that you check the pages that it cites. And right here, you can go into the article and see where it's referencing. And it provides you with follow-up questions you can ask. Below, it gives you important concepts, which gives you some synonyms and research topics. So the difference between the fixed summaries and the research terms is that the fixed summaries provide everyone that's searching this the same information, but if you ask your own question, it's going to alter your results. Another really cool tool on here would be, see if I can find it. It will let you visualize. Okay, see,
Use
I'm
the
not sure.
button there, Blakely, research topics button.
Oh,
I think
okay.
that does it.
So diagrammatic tools, which organize information. Oh, I'm not sure why it's not popping up. Hmm. Well,
Go up to the top, Blakely, and see if the mind map link was in the main summary, the opening summary. Is that still visible? Yeah, I don't see it. I don't know.
mhm.
Maybe because it's a dissertation thesis, or a thesis. Maybe that's why.
Possibly. I was looking
Okay.
at a different
Okay.
article than before. Let's see.
Well,
There's
everyone we're talking about, it can do basically a Java. It looks like a JavaScripted visualization, a mind map with icons connected to different clusters of topics. And it's interesting in terms of just visualizing the related concepts. You can't do much with it. It doesn't have any links inside it, but it is useful for that too. But we might want to move to JSTOR at this point, likely, just so we have time to look at their implementation of
okay.
it.
Okay, that sounds good. Let me see. Switch to the. Oh, it's
There it is.
showing
Yeah.
up. So this map, it shows the information hierarchically and it shows the central concept and branches onto subtopics, which you can do a related search to from clicking on these terms. Okay. So I'm going to open JSTOR. Let's see. Sorry. So in JSTOR, you'll want to make sure that you're linked to your institution, which you can see here at the top. Oh, sorry, I'm sharing one screen. Okay, so you can see at the top where it says access provided by University of North Carolina at Greensboro, and make sure that you're logged into your account. And once you are, then you can use JSTOR's interactive research tool. And so I'm going to show you an example of a Boolean search term based on concepts and research topics that I'm focusing on in my work, which are generative AI, artificial intelligence, culture, and art. So when I find an article that I'm interested in looking at, I will click on it below. Let's see, generative. So generative AI and human, what you can do similarly to the pro is the AI research tool will show up on the screen, and it will tell you exactly what topics it will show and how your search is related to it. And it recommend topics and ask questions using natural language search. And also you can highlight text here, and you can ask questions about the selection. You could copy the text and find related content as well. You can ask questions such as without a question mark. So just typing in effects on students. And so it shows you exactly how generative AI impacts students during this research and overall impact. You can also check its sources by asking or scholars mentioned, and it will cite its sources. The one thing that it doesn't do is let you know if the article is peer reviewed or not. And after you're finished searching, you can save this by downloading it as a PDF, and it will also produce citations based on capabilities.
And of course, whether you should be citing the AI summary or citing the article itself is, a topic of conversation that we should have with our students, right? So that's an interesting feature that they provide for that. Yeah, thank you, Blakely. All right, let me very quickly, I have this all ready to go, show you one last search, and this is the most controversial, and I shouldn't say that. This is, the most extreme use of AI, which is creating answers, writing answers. So switching interfaces a little bit, this is a statistical package, social science and business data statistics called Statista. They have an AI tool. I'm using my same search I did in that EBSCO database to start with, trends in fertility rates in Japan. So what are the trends in fertility rates in Japan? I don't just want research, I want numbers, because that's what the database does. Notice it tells you what it's doing, it's analyzing requests, it's looking at various reports it has and like tables and graphs, and there's the answer. I can still show those processing steps. Up and on the right, I can see my sources. So this is again RAG. This is only looking at this package of reports, which are in PDF, or it's at pages where it just has a graph or chart or a table. And you can see sources there too, World Bank, United Nations, DESA, etc. But also the answer. So it's not just giving me the table or the report. Well, I can click, open it and see what's there. It's giving me what it thinks is a summary. So this again is the most risky, and that critical thinking is most important. And also if we're talking about student learning, whether this enables or detracts from that, that's that's kind of an outcome discussion we could have if we had time, and other related things. So this is one example of a semantic answering system where it gives us the paragraph summary. And again, I can click on sources and get out of the AI. And now this is the normal interface for Sista. And if I choose to see a table instead, I can change it to the numbers, not just the visualization. So just example of creating summary answers slash summaries, basically, of research, which is something that some of these products are now engaging in. And it's 12:30. Ooh, we did well on timing, Blakely. All right, thank you for being here, everyone. Questions, comments, pushback, any sort of follow-up you want to say?
And feel free to unmute and have a conversation. And if we need to stop recording, I am happy to do that. All relevant links in the chat, so y'all have room, time to talk.
Why don't you stop recording, Sam? Thank you. So this